I'm here with Max Bronowitzki, and he is from the University of Bremen in Germany. And Max,
Hello.
first of all, tell us about your experiment. What is your experiment?
Hello. So our experiment, capillary channel flow, this is the project and experiment name, capillary channel flow, which is being conducted on board of the International Space Station. So this is the cooperation between German Aerospace Center, NASA, our University of Bremen, and Portland State University in America. So our project, Capillary Channel Flow, we are basically interested in a fluid behavior in space in a compensated gravity environment. And in particular, we focus on a fluid flow in a capillary channel. So just to give you an idea how does the fluid behave different on Earth and in space, I could give you an example. So for example, when we drive a car on Earth, we need a petrol. So petrol is stored in a car's tank, and due to the gravitational force, it stays on the bottom of the tank. It's obvious and simple to imagine. So it's pretty easy to collect the petrol from the bottom of the tank and transport it to the engine. But in space we have a bit different situation. There's no gravitational force which keeps everything on the bottom. So if we look at the spacecraft or if we look at the satellite, the propellant which is stored in a tank will not stay on the bottom. It will be spread, distributed everywhere inside of the tank. So it's pretty challenging to collect the propellant and transport it to the thruster. So there are some different devices which do the job, and such as vanes, which are basically capillary channels which we are investigating. What we do is a very fundamental science, very fundamental research. So we are trying to understand and describe the phenomena which were not investigated yet. And the propellant management system is one of the examples. But the other applications could be very generally fluid management in space, and not only propellant management system, but also life support system and astronauts which live and work on board on ISS. They use a lot of liquids. It's not only drinking water, and we are planning to go to the Mars, probably with a stopover on the moon. So we will need a lot of liquids, and we need to be able to manage them and transport them. So this is what's our research about, but there are also some Earth applications, such as lab-on-a-chip devices and a variety of microchannels used in a biomedical industry. So all microchannels where these capillary effects, which we are investigating, play a big role. And we've got some results, and it would be not possible to perform such a huge study here on Earth. And NASA gave us this wonderful opportunity to perform these long-term experiments in space, which is great. And you asked about the results, so right. I don't want to go too deep into the details now.
But you do have results.
Yes, but I would like to mention that there is a perfect agreement between the theory and our predictions and experimental results, which is great, and that gives us a lot of motivation for further work. What I would like to say that we really appreciate this help of NASA, and we do enjoy working with NASA together, and we are looking forward to do more experiments, and we do some real serious science, but we have fun, which is great.
That's
mainly
terrific.
Thanks to NASA and MSG team. So
terrific, and he's going for his PhD, so he's a candidate. So good luck with that too. Maybe this experimental will help that along.
Thank you.
Thank you, Max.